write it in the chat session. That said, welcome to today's session. We have participants from different sides. So the first person who is going to present today is the person of, shall we wait for others to come in, or a few more people might join us later? Because it seems we have only 3 people who are part of today's session at the moment. What do you reckon? Anyways, today's session is going to be starting with Ibrahim, Uzairu.
Let's wait 2 minutes.
All right. Okay. Right. I think we have Ibrahim et al. In the house now.
Okay, I think let's start. By the
Yes.
way, Mahamane Chapiou is not available. He called me. He will
Okay.
present in later session.
All right. All right. All right. So today's session commences with the paper titled CH2501, Molecular Docking, Drug Likeness, Pharmacokinetics, Properties, Prediction, and DFT Calculation of some Dehydroandrographolide. Ibrahim et al. If you're in the house, please, your time commences now. Thank you.
Okay, permit me to share my slides. Good afternoon, everyone. I'm Ibrahim by name, here to present the paper. Let me share my slide, please. Okay, please, can you see the slide?
Yes, we can see your slide, Ibrahim.
Okay. Good afternoon once again, everyone here present at this session. I am Ibrahim, here to present a paper titled Molecular Docking, Drug Likeness, Pharmacokinetics Properties Prediction, and Depth Calculation of some anti-hepatitis B virus agents. Hepatitis B is a liver infection caused by the hepatitis B virus, which is usually spread through contact with blood, semen, and other body fluids of an infected person. According to the World Health Organization report, it is reported that about 2.96 million people were living with chronic hepatitis B infection as of 2019, with only 1.5 million new infections each year. There are generally 2 categories of current treatment for the disease. The first one is the immune modulator drugs and the antiviral drugs. And dihydroandrographolide derivatives are the typenoid class of compounds and were reported to have antiviral activity. That is why they are used in this research. And nucleoside diphosphate kinase is a transferase class of protein which provides precursor for DNA and RNA synthesis, and it's also involved in the cell regulation. Computer-aided design uses computational chemistry tools to discover, enhance, and study drugs and related biological activities to the active molecules. Molecular docking is one of the computational techniques, design techniques or tools which involves the prediction of the ligand conformation as well as its position and orientation within the site of protein and assess its binding affinity. whereas pharmacokinetic study evaluate the pharmacokinetic safety of various drugs, including drug likeness and admit property of such drugs. While density function theory is a successful theory which calculates the electronic structure of atoms, molecules, and solids in order to determine their stability or reactivity. Materials and method. These are some of the materials that are used in the course of this work. The figure 1 presents the flowchart of the methodology, or the summary of the flowchart of the methodology. In any computational chemistry work, the first thing to do is the source of data sets. In this research, 36 compounds were sourced from the data sets, were sourced from the literature, which were then used in this research. And before carrying out the main contents of the work, there are some preliminary investigations that must be carried out in order to have good results. The first one is to write structure generation, which is to draw the structures of the compounds that will be used in the research. And then after drawing the structures, they are going to be prepared in order to find the most stable conformation of the structures that were drawn prior to the molecular docking virtual screening. And then before that as well, there is need to get the protein data bank file format of the receptor, which is gotten from the RSCB database. And before it can be used, it is then prepared for the molecular docking virtual screening. In the course of the preparation of the receptor, the receptor is being the software used for this for the preparing of this receptor was Discovery Studio, where co-crystalline ligand that was in the receptor is being removed after successfully identifying the active site of the compounds, the active site of the receptor. And then for the virtual screening, in order to identify a potent most active compound, molecular virtual Docker was used in order to virtually screen identify potential leads among the studied compounds. In this regard, after identifying the most potential potent compound or the lead compound, then the pharmacokinetic property prediction of these compounds are ascertained. And then after that, DFT calculations of the most active compound were also predicted using Spartan 14 software. And then for the pharmacokinetic properties, the software that was used or the online tools that were used are the SwissADME and the PKCSM online web tools. Results and discussion. Table 1 presents the molecular data result of the best 5 compounds due to time constraint and then the space to manage the space. Only 5 best compounds are presented among the studied compounds. Among the studied compounds, compound 9 was identified to be the best compound with the Moldog score of minus 175.178 kilocalories per mole. After successfully identifying the compound, then the mode of binding interaction of this compound with the active site or the amino acid residues in the binding pocket of the receptor were portrayed as shown on the table as well. The compound was seen to have interacted in the active site of the protein with the specified amino acid residues at different distances as shown on the table. And also hydrophobic interaction were also noticed or observed as shown on the table with the specified amino acid residues at different distances. Besides compound 9, compound 8 was also identified to have a higher binding affinity of minus 171.76 kilocalories per mole. It was also observed to have interacted in the binding site of this protein with the specified amino acid residues as shown on the table 1. And also, it was also observed to have formed in hydrophobic interaction with other amino acid residues as specified or as shown on the table. Beside these 2 compounds, also compound 2 was identified to have a higher binding affinity, which form also hydrophobic interaction and hydrogen bond interaction as shown on the table. And then beside compound 982, compound 10 and 6 were also seen to have a higher binding affinity as compared to the standard drug that is being used for the management of hepatitis B virus, which is chrysin, which is observed to have a Moldog score of minus 94.78 kilocalories per mole. And this compound was seen to have interacted in the active site or binding site of this receptor with these amino acid residues as shown on the table. And also it was observed to have formed hydrophobic interaction with these two amino acid residues as well as shown on the table. When we look at these compounds, we see that all these 5 reported compounds were seen to have better binding affinity than this standard drug that has been used or that is being used for the management of hepatitis B virus. And all these compounds were seen to have formed hydrogen bond interaction, hydrophobic bond interaction in the active site of the receptor. Figure 2 presents the 2 interaction of compound 9 in complex with the receptor used. When you look at the interactions, we see that the amino acids presented on the table are the ones here in the figure, which shows the figurative description of the compound 9 in complex with the receptor. Then, after assessing virtual screen, identifying the best lead compounds, then drug likeness of these compounds were also predicted following different criteria. Among the criteria used, one of them, which is the Lipinski's rule of 5, which said that a compound is said to be orally bioavailable if it does not violate more than one of the stated criteria, which should have molecular weight less than or equal to 500, and then hydrogen bond acceptors less than or equal to 10, hydrogen bond donors less than or equal to 5, and then M-log p-value less than or equal to 4.15. When we look at these compounds, we see that they only have one violation, which is the molecular weight. And these compounds can easily be said they are orally bioavailable as they have not violated more than one of the Lipinski's rule of 5. Besides the Lipinski's rule of 5, there are other rules that were assessed, which can be shown on the table 3, which presents the summary of the filtering criteria used for the bioavailability score and synthetic accessibility score. Then, for the Lipinski's rule of 5, all the compound except compound 1 has 1 violation and compound 6 with 0 violation, which indicates that the 4 compounds excluding compound 10 are orally bioavailable with synthetic accessibility score of 5 points in the range of 5.47 to 6.15, which indicates that these compounds can be synthesized in the wet lab. And then beside the Lipinski's rule of 5, Weber's, Egan's, Milk rules were also used, out of which only compound 10 has, for Weber's rule, none of these compounds violated the rule. As such, it can be said that these compounds obey the Weber's rule. While the Egan's rule, all the compounds were seen to have 0 violation with the exception of compound 10, which violated 2. By mere looking, this compound can.
You have 5 minutes more.
Okay, noted, sir. By mere looking that this compound cannot be used as a candidate drug, as it has not obeyed some of the rules used for the drug likeness property predictions. And then by looking at the bioavailability score of these compounds, we can see that all the compounds, they have 0.55 bioavailability score, which indicates that, except compound 10, which indicates that these compounds are easily which indicates that these compounds are bioavailable with no drugability problem. Then table 4 presents the admetoxic property result of the base compound. For this assessment, the association, distribution, metabolism, excretion, and toxicity of these compounds were all predicted. For this intestinal absorption properties, all these compounds were seen to have passed the 30% minimal threshold value set for this property, which indicates that this compound can be absorbed within the human intestine, while the blood-brain barrier permeability and the central nervous system, all these compounds were also seen to be within the range, which indicates that from minus 2 to -3. And then for the metabolic processes, There are different isoforms for this, but for this, for the most important among them is the cytochrome 3A4, which drug is expected to be both substrate and inhibitor of this cytochrome. For these drugs, or for these compounds, all of them were seen to be both substrate and inhibitors of this cytochrome, which indicates that these compounds can be the metabolic pathways or metabolism of this compound.
You have 3 minutes more.
Okay, can be studied. And then the total clearance, which indicates how drugs can be screened out or can be taken out from the body. We can see that all these compounds, except compound 9, have the value within the accepted range of from 0.1 to 0.8. Then all these compounds here seem to be non-toxic, which in summary indicates that these compounds have good ADMET properties. Then for the DFT calculations, the HOMO-LUMO of these compounds were computed and the energy gap was calculated. And all of these compounds were seen to have lower band gap as compared to compound 2 and 6, which have the lowest band gap, which indicates that these two compounds are most reactive and they are less stable. And this figure 3 shows the HOMO-LUMO energies of compound 2 and its band gap. Conclusion: based on the molecular decking carried out, the lead compound with MolDoc score of -175.17 kilocal per mole ranked the highest than chrysin, which is the most standard drug used for the treatment of hepatitis B. And all the compounds are predicted to be drug-like in nature, with the exception of the compound 10, and they are orally bioavailable. The ADMET properties of this compound show that they all have good ADMET properties and were non-toxic. Furthermore, the DFT result shows that this compound, compound 2, with the band gap of 4.3 electron volt, and compound 6 with same band gap are the most reactive in the series of the compound investigated. These are some of the references used. Thank you all for listening.
Thank you very much, Ibrahim et al., for that wonderful presentation. If you have any question, could you please signify by showing your hands emoji? Then we can take questions on the paper just presented by Ibrahim et al.
I just want to thank Dr. Ibrahim for his nice presentation.
Yes. Right. That's a good comment for you, Dr. Ibrahim. Thank you very much for presenting. In the absence of question, we proceed to the next presenter, and that's CH2505, Evaluation of Wet Digestion, QuEChERS-DLLME for Heavy Metal Determination in Aqueous Solution by Akilu et al. Is Akilu et al. In the house? Okay, Akilu et al. Yes, he is here. All right.
He's here.
The floor is yours. Your time starts now.
Akilu, start your microphone. We cannot hear you.
We cannot hear you.
Your microphone.
Now we could hear you, but then, yes, welcome. Oh, okay. I think Akilu et al. Is probably having some internet connectivity problems. In the meantime, we'll proceed to the next presenter. See, are you here, Akilu et al.? I think we can barely hear anything you say, sir. We'll proceed to the next presenter then. CH2503. A comparison study of wet digestion. Oh, it's Aminu Akilu et al. Again. Are you able to connect, Mr. Akilu, Dr. Akilu? We cannot hear you, sir. connectivity problems.
Probably he's having some problems.
Yes, he is having connectivity problems. Well, we're going to proceed to the next presenter. That's Mohammed and Aminu Musa. And the paper is titled A Review of Biodiesel Production Using Eggshell as a Catalyst. Alimatu Ibrahim et al. In the house. Halimatu Ibrahim et al. Okay. Then we proceed to the next person. CH2509, synthesis of new pyrazole, I cannot pronounce this word, derivative via a multi-component reaction. So Hanura, are you in the house?
Hello, do you
All
hear
right.
me?
Yes, we can hear
Okay.
you. Please
Okay.
proceed to
I will
presenting your
share
paper.
my screen.
Your time starts now. Right, the floor is yours, please.
Okay. Can you see my screen? Hello?
Yes, we
Yes,
can.
we can. Yes, we can. Yes, we
Okay.
can see your screen now. Yeah.
Good afternoon, everyone. First of all, I would like to thank the scientific committee for accepting me to attend the 9th International Student Science Congress. I'm so excited to present my research on synthesis of new pyrazole pyranopyrimidine derivatives via a multi-component reaction, a promising class of compounds that have attracted significant interest in recent years due to their diverse pharmacological properties. This work was conducted at the Laboratory of Chemistry and Environmental Chemistry at University of Batna, Algeria. Green chemistry focuses on creating environmentally friendly chemical processes in order to reduce waste. An example of this approach is multi-component reaction, which allow for the synthesis of complex molecules in just one step, as is shown in this scheme. These reactions often use water as green solvent for its benefits in controlling reaction conditions and reducing waste. Catalysts like L-proline and DMAP have proven to be particularly effective in promoting eco-friendly transformations. They enhance the reaction efficiency and selectivity. So pyranoperazole pyrimidine derivatives are a class of heterocyclic compounds known for their diverse biological activities, such as antimicrobial, anti-cancer, antiviral, etc. Additionally, substituted pyrimidines and pyrazoles are highly valued in drug development due to their therapeutic potential. As a result, synthesizing these compounds efficiently and sustainably is very important for pharmaceutical research. Our study aims at investigating the use of green catalysts, especially L-proline and DMAP, in the efficient synthesis of different pyranopyrimidine derivatives through multi-component reaction. So by optimizing environmentally friendly conditions, we hope to develop new methods for synthesizing these compounds with potential therapeutic applications. We present here two examples of pyranopyrazole derivatives as antiviral activity. Also, we present here two another examples as anti-cancer activity. For the purpose of optimize the performance of reaction medium, we carried out the condensation of benzaldehyde derivatives, acid barbituric and pyrazolone, with the addition of various amounts of catalysts, which are L-proline and DMAP. and also different protic solvents as water, ethanol. Sometimes we put here mixture of ethanol, water, and without solvent at 100 degrees Celsius. So the best results were obtained by using 200% of DMAP and 10%, 10 mole percent of L-proline as shown in this table. And we use the water as a solvent, which give us the highest yield at reflex. So after optimizing the reaction conditions, we have successfully synthesized 14 derivatives of pyranopyrazolopyrimidines. Among these 14 compounds, we have 4 compounds are new compounds. This table summarizes these derivatives along with their respective yield and also the time and the measured fusion melting point. So we present here the NMR proton spectrum of one of these derivatives, which is the methoxypyranopyrazolopyrimidine. So the proton spectrum shows one signal at 13.7 integration 1 proton attributed to NH and to one signal integration to proton attributed at 10.14 attributed to these two NH. Also, we have 4 signals at the interval 6.57 to 7.15 integration for H attributed to these proton aromatic protons and one singly at 5.14.40 attributed to CH, this proton linked with the aromatic cycle, and one signal integration 3H at 3.67 attributed to methoxy group. And finally, one signal at 2.18 integration 3H attributed to methyl, which is linked with the pyrazolone cycle. So as conclusion, we have successfully developed the use of DMAP and L-proline as environmentally friendly and effective catalytes for synthesizing pyranopyrimidines thermometric component reactions. Our results highlight the importance of synthesizing or developing these approaches in organic synthesis, especially by using the water as a solvent, by carefully adjusting reaction conditions like temperature, concentration, and the amount of catalyzed. We were able to improve both the efficiency and the yield of these derivatives. This research adds to the growing effort to develop sustainable and efficient methods in chemistry, which could play a significant role in medicinal chemistry by helping to design new therapeutic agents that are both effective and environmentally responsible. As perspective, we are willing to study the molecular docking and also the biological effect of the synthesized derivatives. So thank you for your kind attention.
Dr. Chua, thank you very much for your wonderful presentation. I believe we all need a cleaner environment. And of course, your research is doing a great job at achieving that for us all. In the meantime, if you have any question to ask Dr. Chua about our presentation, please show your hands and you may go ahead and ask the question. Yes, bro.
Thank you for the presentation, Dr. Nura.
Thank you.
Is the material, I say it material because it's hard to pronounce it, is it related with cancer therapy?
Yeah, as I have shown here as examples, I found in literature many compounds of pyranopyrazole pyrimidines are confirmed for their anti-cancer activity, and I'm willing to study the anti-cancer activity for my for the new structures that I have synthesized. Yeah.
Okay, then it will be useful.
Of course, yeah, this is the aim of, this is why we targeted these molecules.
Yes, that's very nice. Okay, thank you.
Thank you for your question.
And thank you for making that presentation very brief and within the limit of time. That's a very wonderful feat. Yes, this time we have Dr. Aminu Akilu. Are you able to present now? Dr. Aminu Akilu, are you able to present now? Okay.
I think I may present.
Yes, please go ahead.
Can I share?
Yes, you can. Stop.
My presentation. Is it okay?
Yes, it is okay. Please go ahead.
Yes. My presentation is related with the master thesis of my student, Altınay Abdurrahmanova. She is from Kazakhstan and she is unable to connect, so I will present the topic. It's related with sustainability and urban transformation. The sustainability and socioeconomic impacts of urban transformation strategies in the case of Astana. And Altınay is from Kazakhstan. Astana is the capital city of new capital city of Kazakhstan. Let me give a short definition of urban transformation. It's the comprehensive process of reshaping urban spaces through redevelopment, modernization, and sustainable practices to enhance a city's physical, social, and economic well-being. Astana, as the capital of Kazakhstan, new capital, has embarked on an extensive urban transformation that redefines not only its physical landscape, but also its social and economic dynamics. Therefore, the aim of this study is to assess the success of Astana's urban transformation, identify the challenges encountered, and explore its potential from a multidimensional perspective. Let's talk about Astana's transformation. There are plans and there is a strategy. After being designated the capital in 1997, before that time, Almaty was the capital of Kazakhstan. Now it's Astana. Astana was strategically located to overcome expansion limitations and mitigate natural disaster risks. I think you can see the location of Almaty here, the previous capital, just near the Kyrgyzstan border and also close to China. Therefore, for several reasons, the capital was moved from Almaty to Astana, to a central location in Kazakhstan. Since then, it has evolved into a modern, well-organized metropolis defined by a meticulously planned urban layout and iconic landmarks created by internationally renowned architects. This figure shows the huge difference, huge change from the year 1999 to 2014 in Astana. As you can see, in those years, it was just like a very simple village, and now it's really a metropolitan city. what was the procedure? What was the reasons in this strategy? Population changed from 300,000 to about 1 million in this time after it was designated as the capital city, and there was a necessity for large-scale implementations of housing, infrastructure and transportation projects. Also accelerated economic activities. Many national and international companies' headquarters were located now as it became the capital. It was also defined as a political and cultural hub, as Astana has become the political center of Kazakhstan. So it was a focal point for many cultural and international activities. It needed the city needed new infrastructure and transportation facilities. Therefore, with modern highways, bridges, and public transportation systems, urban mobility has improved. Astana International Airport, a new one, has transformed the city into a globally accessible destination. Also, there was environment and climate action. Harsh climate, because it has a harsh climate with winter temperatures dropping as low as minus 40 degrees centigrade, very low temperatures. This reality has been taken into account in urban planning and building design. And this figure shows the roadmap projects. This is called Nurli Yol. That means the bright road. Nurli Yol means bright road projects. This is the capital, and many new highways were constructed, designed to modernize Afghanistan's infrastructure. This project diversifies its economy away from heavy reliance on natural resources and boost economic development. As we all know, Kazakhstan economy relies on natural resources like oil and natural gas. So the government wants to change this reliance with new agents, new resources, and aims to position the country as a strategic trade and logistics hub between Asia and Europe, upgrading transportation, energy, agricultural and industrial sectors, and also enhancing social services and living standards. Astana 2030 City Development Plan was also implemented with the long-term vision to transform Kazakhstan's capital into a modern, sustainable, and smart metropolis through infrastructure modernization, economic development, and environmental sustainability. Also, it was aimed to make the urban development eco-friendly, emphasizing protecting green spaces, expanding renewable energy, and upgrading transportation with smart city technologies. And also, it focused on attracting international investment, developing Astana as a trade and finance hub, and improving living standards via housing, education, health, and cultural services. Also, digital transformation integrated advanced technologies such as 5G and others, smart management. And during this procedure, Japan International Cooperation Agency prepared or developed a master plan. It was an award warning plan, which is based on concepts of metabolism, recovery, ecology, and symbiosis. Also, nature infrastructure integration was aimed, including ecoforests for wind protection of the city, landscape flood embankments, and natural green network organized along 8 axes of the city to enhance aesthetics and resilience. About the environmental sustainability approaches, green buildings and natural and energy efficiency. Well, there are some examples for green buildings. One of them is Nur Alem Pavilion Sphere, and the other one is İriskeldi Hacı Mosque. Another one is the mentioned master plan by Japan International Cooperation Agency, and also nature infrastructure integration. And I want to mention about this interesting building, Nur Alem Pavilion Sphere. Nur means shining in Arabic, as you all know, Nur, and Alem is the word for world, globe, or earth. So it's a very big sphere, spherical building with a diameter of 80 meters. The design concept was the last drop of oil before the era of green technologies, and it's Kazakhstan's first technological museum of the future dedicated to energy. And the specific concepts were space energy, solar energy, wind energy, biomass energy, kinetic energy, and water energy. There are 6 terms here. The building inside is 8 floors. 6 of them are these, and there are 2 other floors. And it's an interesting building. It has solar panels all covering outside of the building. And even on top of the building, there is a wind turbine, as you can see on the right figure. Another example structure is İriskeldi Hacı Mosque. It's also an interesting building. It has solar panels covering the huge building. And this is the world's first mosque to implement 0-watt technology. That means fully meeting its energy needs through renewable sources. And it's an attempt in sustainable energy contributions. It contributes to the cities, Astana's electricity system, but since the city is not a sunny city, the days are limited, sunny days are limited. There are environmentally friendly solutions because Astana focuses on eco-friendly building projects with energy-efficient technologies. Government buildings incorporate smart lighting, insulated windows, and water-saving devices. Residential developments use insulation technologies to reduce energy consumption. The city's large area supports wind energy projects alongside solar panel use, and smart technologies also optimize energy use in traffic lights and street lighting. And with this economic and technological transformation,
You have 5 minutes, sir.
Okay, thanks. There is also a transformation in the social structure. Since 1998, Astana has rapidly transformed into a diverse, dynamic capital, attracting both internal and international migration. Economic growth fueled by oil and investment has created a new middle class, demanding modern housing, education, and cultural services. And this rapid urbanization has increased socio-economic inequalities and social stratification. And the government started another initiative, Ruhani Yangiriu, which means in English spiritual renewal, or in Arabic Ruhani Zengru, or Aydınlanma in Turkish, Ruhani Aydınlanma, initiative in 2017, which promotes national identity and cultural heritage alongside modernization and global integration. Women's roles were evolving in the development of the city, Astana's urban landscape and digital culture have reshaped social interactions with education reforms. Urban transformation also improves quality of life by creating modern, safe neighborhoods, but these have both advantages and disadvantages. Modern cities, safe neighborhoods, it looks good, but it has also some handicaps. Public spaces like parks, community centers enhance social interaction. Economic growth from new business and commercial zones generates local employment opportunities, and the risks include displacement of low-income residents because the segregation or stratification is increasing. So there is a loss of cultural heritage. This is the main risk, loss of cultural heritage. Successful urban transformation requires inclusive, socially balanced planning with community participation and protection of historical identity. This is a table of evaluation, general evaluation, the achievements and the challenges of each item, each issue that I mentioned. So I will share this with you, but I will not read all the details because I mentioned all of them in my presentation. And as a conclusion, Astana's rapid transformation highlights ambitious urban planning and strong sustainability efforts. Key strategies like Astana 2030 plan and Nurli Yol program focus on modernization. Investments in transportation, green buildings, and smart technology support its goal as an international trade and finance hub. But the challenges such as population growth, income inequality, and energy demands require adaptive, inclusive solutions. Green energy projects and cultural initiatives demonstrate commitment to sustainability and social cohesion, and Astana's ongoing evolution offers a globally relevant model for balancing modernization with environmental and social properties. And I want to thank you. And if there are any questions, I want to answer the questions.
Thank you very much, Professor Shadiq, for the wonderful presentation. You've basically taken us through Astana, the capital of Kazakhstan. If you have any question, please do not hesitate to ask them questions.
I think, by the way, Akilu tries to connect. Can you hear us? Akilu, he sent me his presentation. I'll try to share it with you.
Oh, that's good. Right. He has two presentations. Then we can just proceed to his presentation in the absence of questions. Welcome, Mr. Aminu, Dr. Aminu Akilu. Please, the floor is yours. If you're ready, you can present your paper. Set problem. Dr. Aminu Akilu, are you able to connect now? Oh,
I will share his presentation.
Okay, thank you, Prof. Yes.
Can you see?
Yes, we can all see QuEChERS for heavy metal determination accused. Dr. Akilu, are you able to see your presentation as presently being displayed on the screen? If you could you please go ahead and present it? Your microphone is muted. Your microphone is muted. We cannot hear anything you're saying. Yes.
Let me at least slowly pass the slides.
Okay.
QuEChERS, quick, easy, cheap, effective, rugged, and safe method when coupled with dispersive liquid-liquid micro extraction represents an innovative and efficient approach in analytical chemistry for the extraction and determination of contaminants in complex matrices, including environmental and aqueous samples. This study evaluates the efficiency of the QueChERS-DLLME method in comparison to traditional wet digestion for the determination of 5 heavy metal, nickel, cobalt, chromium, cadmium, and lead in aqueous solutions. A known final concentration of 64 ppm in wet and 38.5 ppm in QueChERS-DLLME of each metal was analyzed using AAS. The findings indicate significant metal loss with the VD method, resulting in low recovery rates compared to the given method. Nickel exhibited a higher concentration compared to the present method, while the latter method yielded higher recoveries for copper, cadmium, chromium, and lead. In contrast, WD produced lower values for copper, cadmium, chromium, and lead. Akilu, you may continue. So we shall continue again. For many years, wet digestion techniques have been used as effective ways to analyze heavy metals, refractory elements which can and will withstand treatment with the strongest acids, including HNO3, H-chlorine, H2SO4, H-chlor. Since I'm not a chemist, I cannot read everything.
You did a good job.
In many samples, the surface temperature has the potential to burn off organic materials such as carbon dioxide and water. Once chemicals used for digestion are...
I think he's able to present now. He just came on.
Available now. I can present.
Yes, continue then.
I can present. I can go ahead now. Introduction. For many years, wet digestion techniques have been used as effective way to evaluate heavy metals. These were presented by these researchers, 2015. Refractory elements which can and will withstand treatment with the strongest acids. All these acids that are being used in wet digestion, there is some sample that can withstand the use of this acid or mixture of it in a certain ratio. So, as such, the idea of developing a new method in which it can be used instead of wet digestion is very important. Wet digestion, this is a simple procedure in which I use in the wet digestion process. 2 ml of prepared 100 parts per million standard working solution, which contains a mixture of all the 5 elements mixed and sparked in 6 ml of water, which is a medium. Mix thoroughly, then we stand for 5 minutes to ensure even distribution, and the 5 ml HNO3 concentrated nitric acid were added, and so on and so forth. Then this is the procedure of QueChERS coupled with DLLME. This is a continuation of the procedure in which after you run the QueChERS, then you couple it with the DMME. So this is the final, and finally determine the sample solution using, analyze the sample solution using AAS to know the final concentration of each and every analyte. At the end, these are the results of weight and QueChERS coupled with DLLME. The initial concentration of each element, nickel, cobalt, cadmium, chromium, and lead, in weight digestion is 67 parts per million, which is after you add all the digestion solutions, you use the dilution formula and know the exact concentration. Initially, the concentration is 500 parts per million, but after addition of all digestion solution, by using dilution formula, the concentration turns to 67 parts per million. And again, in the QueChERS coupled with DLLME, final concentration, it is now 38.4 parts per million. And at the end, these are the results. If you look up the two results, there is so significant differences between weight and the QueChERS coupled with DLLME. These are the brief discussion of the result. If you look at the result critically, you will see the concentration tallies with this concentration of cadmium is greater than nickel and greater than continuously in this series. It obeys this series. And again, in QueChERS coupled with DLLME, it follows this series in increasing order. Then conclusion, the result is demonstrated that QueChERS coupled with DLLME is more effective method for heavy metal analysis. This is very obvious in the analysis of chromium and more obvious in cobalt, cadmium, and lead. It offers advantages such as reduced reagent. It required a little amount of reagent consumption, low environmental hazard. All these the organic solvents are environmental friendly. They have no effect. These are some references.
We can't hear you anymore. Your audio is not coming through. Akilu.
Everything was going nice, but
Until
again, we cannot hear you, Akilu.
These are the discussion of my results. In wet digestion, the average concentration of heavy metal was the concentration of cadmium is less than concentration of nickel and is less than concentration of cobalt, then continuously up to the chromium. Whereas in QueChERS coupled with DLLME reported that the following order cadmium is greater than concentration of cobalt and is greater than concentration, the series, it somehow look alike, but only in few elements that it's not similar, that are not similar. This indicates that the weight digestion is not as effective as QueChERS. The results, in conclusion, the result demonstrated that QueChERS coupled with DLLME is a more effective method for heavy metal analysis. This is obvious in the analysis of chromium and more obvious in cobalt, cadmium, and lead. It offers advantages such as reduced reagent. It requires little amount of reagent, low environmental hazards, simplified instrumentation, and improved recovery rates. These are some of the references. Thank you for this.
Oh, thank you very much, Dr. Akilu, for that presentation. Whichever way we were able to understand that you attempted to, inform us about wet digestion and some cheap tools that can be utilized to solve the problem of heavy metal. So if you have any question as regarding the presentation of Dr. Akilu on evaluation of wet digestion and QueChERS-DLLME for heavy metal determination, make your solution, please show your hands. In the absence of that, I believe you have another presentation, Dr. Akilu, don't you?
Yes. If you send the other presentation, I can also share it. Akilu.
Yes, I hear you. Go ahead.
I believe that there are two presentations that your name is attached to. So I'm asking if you were interested in presenting the second one, or if you have it ready, you might send it to Professor Shebik, and we can just open your PowerPoint while you talk to the slides.
The first paper and the second paper have the same title. So presenting one is almost the same thing. So no need to repeating another paper. They have the same title.
All right, thank you very much. I think we have cleared that. In the absence of that, I believe that the last paper is CH2508, a review on biodiesel production using Eggshell as a catalyst by Alimatu Ibrahim, Ahmed Lawal Mahshi, Ismail Muhammad, and Aminu Musa. Are you in the house? Ibrahim et al. Okay. In the absence of the last presenter, first of all, I would like to first appreciate you for joining our session. It has been a wonderful avenue to share knowledge. Every participant, we appreciate you coming to this wonderful presentation. Also, if you can, we would like you to show your camera just for a group photograph that will serve as a reminder of how wonderful this session had went, and also your presentation certificate, your certificate of presentation or participation will be sent to you electronically. So you have your name, the paper you presented, and of course the appellation and signature of the chair or the head of the Congress in the person of Professor Shebik. It has been a wonderful presentation again. If you can, please show your camera so that we can take a group picture together. That will serve as a reminder. And also, if Professor Shebik has a thing or two to say, please, Ojam. So let's jump in environment. Okay. Could we please all open our camera so that we can take a photo, if it is possible?
Yes, doctor. We are good to go.
All right. Thank you very much. Operate screen. Right. Right. Thank you very much for joining our session. It has been a wonderful opportunity to get to know you. Hopefully, next Congress, we will all have the opportunity to share our opinions and our ideas as they come true by the leave of Allah. Right. Thank you very much. And that is it today.
Thank you so much, doctor.
Wish you all the best. Professor Shavik is here. Perhaps he has something to say. Hocam, söyleyeceğiniz bir şey var mı?
I want to thank everybody for the presentations. Although we had some technical problems, but unable to solve it sometimes. So nice to meet you. Nice to see you here with us. We are honored to host everybody in our Congress. And we can take a final photo together if everybody starts their camera.
Thank you so much, Prof. We really appreciate your kind gesture and the organization for the conference.
Thank you.
We hope to see you in our next in your next Congress by God's willing.
Inshallah, we hope to see you again.
Thank you so much, Prof. Jazakumullah khaira.
Okay, is Selva Alizadeh here? And Xiaomi, can they start their camera? Nura, we also are pleased to see you in our Congress. Congratulations for the nice presentation. Nura?
Hi.
Hi. Thank you for your presentation.
Thank you for you. I'd like to thank everyone here. Thank you for giving me the opportunity to attend this international conference. I really appreciate this. It was a great opportunity for me.
Thank you, Nura. We hope to collaborate.
I hope, yeah.
It's like I saw one of you presented molecular vacuum, and my field of expertise is computational chemistry.
So I'm
okay, Ibrahim, so you have my email and you can contact me for this purpose.
Okay, thank you so much. I will do that.
Yeah, thank you for you.
Okay, that's good. Right. Hocam, Sabah Alizadeh, Jomi, onlar katılmayacaklar. Sizce çekecek misiniz? Ben mi çekeyim?
Ben çekiyorum. Buraya bak, kıpırdama. Evet. Taking photo. Yes, okay. Everybody. Okay, done. Thank you, everybody. See you.
Bye-bye.
Bye-bye. Bir yerde baktın mı?
sauki aka ne sauki aka kasashe daban-daban an yi hotuna da sauransu wannan shi kuma online ne gida biyu ne suka kasa shi duk kuma hanya ce wata samun kuɗi da an kirkir conference aka abin ga saboda tifa in kai submitting za ka biya kuɗi ne kafin a approve to su kuma wani sa'i ma kamfani ne ke ɗaukar wannan nauyin rige-rige ke da wace gudu ta idan zan kunnu shi suka bude shi wacan daga can su suka bude shi sai dai na ta diba da nan ina abin ka da ban san ta ina zan bude shi ba kuma kyamara na ɗauka ta ni kuma na bude ina karanta sai dai da na tura mashi ya ce to Amina Akilu Dr. Amina Dakta na haida Dr. Amina Akilu ya tulo slide okay.